In this video, very simple circuit from a 1 transistor active audio filter. Now in the middle of the screen the amplifier stage, consisting of 1 transistor. With this potentiometer we set the output level, and here at the input a kind of very simple demo filter, only to show some principles. This is the classical way to show a filter in this Dutch book. Input impedance, output impedance, and here the filter. Here I have made also a filter. Here it has an input impedance, an output impedance, and we amplify the signal that is coming out of the filter. When you want to make a filter you have to mimic the real situation. So this filter is made for a transistor circuit. When you want to make a filter for a tube circuit, do some experiments with a tube. The input impedance from a tube is much higher. So when you make a calculation for a transistor circuit, it will not work exactly in the same way when you connect that filter to a tube input, to the grid from a tube. There's always loss. That's compensated here in this amplifier. The output level is important, and the input level. The input level is, in my example, approximately 0.8 up to 1 volt. Output the same. That are standard values for consumer audio devices. And every filter at the output from the filter there's a kind of damping caused by the input resistance from this circuit, or the input impedance. When it is low, it has another effect on the frequency that you hear, and when it is high, you will hear another part of the spectrum better amplified. So let's go to this circuit. That's the demo circuit. 1 transistor amplifier here. 1 transistor, output volume, input cap, output cap, both 660 nanofarad. Here is the simple audio amplifier. Here's my loudspeaker box. This are not very high quality devices when you want to make audio filters. Use, for instance, for the end amplifier a good quality 5 watt or 10 watt amplifier and a good quality loudspeaker box. But this is only a demo, so I want to show now how it works and the effects from capacitors at the input from such a simple 1 transistor audio amplifier. By the way, this amplifier has a flat characteristic, amplifies all frequencies between 20 Hz and approximately 18 or 20 kHz. But here at the input, this filter, we can make the sound that we hear in such a way that our personal ideas about sound are heard. So let me demonstrate that. First, I make here a connection between this cap and the input. Here we have an input cap, resistor, and we will hear now that all the high frequencies are cut off here when we connect here a capacitor from 330 nanofarad. Now the cap is connected. No, sorry, it's not connected. I'm going to connect the cap now. And we can hear that the high frequencies are gone. this is the real situation. In the next part, I connect the cap now. No cap and the cap. So all high frequencies are going to ground now, here. But now we're gonna make another connection. While we have the cap here where all the high frequencies are damped, we make a new connection from the input, from the circuit, via cap to the collector, and that means that apart from the audio signal directly travels here to the output. Another part is amplified, the lower part, because here we cut off all high frequencies, the lower part is also amplified. Let me make that connection. I make that connection now. I connect it now, this cap, 100 nanofarad cap, to the collector, here, to this location. You can hear the difference. Now I connect the cap. Now I disconnect the 330 nanofarad cap. And you can hear now already that you have two sound characteristics, sound patterns. Now I connect that 100 nanofarad capacitor to the emitter here. Let's hear. So, in fact, we have now made a circuit in which we can set three sound patterns, sound characteristics for your home audio set when you want to make such a circuit yourself. Very, very simple. You can do experiments with the value from this cap, with the value from this resistor. That will also have an effect, surely have an effect. I can show that now, perhaps. When I turn the resistor, disconnect one cap, connect it again, connect it to the collector. So, with this very simple unit, you can create approximately 6 sound characters. When you make, for instance, this resistor variable via switch. You have to adapt it to a lower value, I have to say that. But do some experiments. Try it, test it out, see and listen how this filter works and whether it suits to your personal choices of how a sound system has to sound.